Good morning, developers. If you are new to the channel, my name is Rob, and on this JavaScript Tuesday, we are going to talk about closures, and by extension, we need to talk about scope. Scope, hopefully you have some notion of already, but to make sure we're on the same page, we'll go over it. Closures is a little more scary. At least it was for me. I didn't understand it at all, but like most things in JavaScript, you just need someone to explain it to you, and it actually makes a lot of sense, or at least it can make sense. We'll start with scope to make sure we're on the same page. Scope is essentially what or who can see a given variable. There's lots of fancy ways to describe it, but that is a simple way to think about it. Let a equals 1. If right below that we have a function, I'm going to call it run, open, close. Inside here, we can console.log a, and that will work just fine because a function can always see what is in the global scope. The global scope are variables that have not been defined inside of a function. What we can't do is down below, if we log, and we'll say that we make a variable in here, let b equals 1, we cannot console.log b. That is not going to work because the parent or the global scope cannot see inside of a function. A function can always see up. The parent cannot see down. As a good illustration, at least that has served me well, think about this as if you were a parent. If you were a parent and you go to the grocery store, the supermarket, whatever, and you buy some cookies. You bring them home. Where do they go? Well, they go in the pantry or wherever the catch-all is for your food. The kids can go into the pantry and get some cookies. That's just how it works. On the other hand, if the kids save up their money from whatever source and go to the grocery store and get some cookies, those do not go in the pantry. The parents do not have access to those. Those go into some special place in the bedroom or wherever. JavaScript works exactly the same way. Something that is defined higher, right? A parent thing, that is always accessible to the children, right? To the functions inside. But stuff that's defined inside functions cannot be accessed above that function by the parent. Okay, so going a little bit further here. If we define a function inside here, so we'll have a function, I'll call it child, open, close, brackets. Inside here we'll have let c equals 1. Who has access to c? Only the child, because there's nobody inside of this. Do they have access to it? Can run see it? No. Right? Parent cannot see a variable inside of a child. Can the global scope see it from either of these spots? No. Nope. Parents and global scope cannot see inside of child functions. Where do closures come in? Let's hop over to the code editor quick and take a look. I have a file called closures.js opened up. I'm going to use Node to run this, which is simpler and a little bit faster. Please feel free to use an HTML file. If this is intimidating and you want to follow along, just put script tags in it and open it in the browser. I'm going to go over this code quick and then we will run it. On line 1, it's pretty much everything we had on the board. We've got an a equals 1 globally. We have a function called parent. Inside there, we have access to a. It's just fine because these are the parent's cookies. We define a child variable called b. We have a function called child where it has its own variable c, just like on the board. And then we return the child. We'll come back to this in just a second. Just ignore it for now. We've run parent on line 13. This, again, is going to be just fine. All this is going to be fine. Line 14, we try and console.log b. This is ... trouble, right? Whose cookies are b? They belong up here to the parent. The global scope won't be able to see that variable, and we will get an error. So if we come over and run node on closures.js, there is the number 1, and then again, b is not defined because it is not accessible. I'm going to comment out both of these, and we're going to come back here to our child. Child is being returned by parent. That means if we come down here on line 13, I'm going to do const, and we'll call it run. Okay? Run is what? Run equals a function. Child up above. We have stored a function inside of run, so we can do this. Run, open, close. That will work just fine. Why? Because this variable run contains what? The return value of parent. What's the return value of parent? It is child. What is child? Child is a function. So we're able to run or execute run because it is a function. What are closures? I'm going to put this, let's put this back up at the top here above parent. Closures, a child function will still have access to its parent's variables even after the parent is done running. So if nobody can get back to the parent, but there is a way to get back to the child, we will still have access to that variable. This is usually going to matter when you return a function, because otherwise, if I get rid of this, and let's say we just simply call child, well, there's no way to get back to child either. Once parent is finished running, child will also be finished running. But if we return child, there is a way to get back to child. It is through run. Closures say that a child function will still have access to its parent's variables. In this case, I'm going to throw in here console.log C plus B. C is a local variable, B is a parent variable. When we call run, what we're really doing is calling this function here. We're trying to access B. Well, parent is done. We're not calling parent anymore. We're calling child. But because of how scope works and because of how closures work, B will still be accessible inside a function. We're going to expect 2 to show up, clear out the console, run our code. Sure enough, we get 2. That is closures right there. What is a quick use case here? I'm going to comment out C because we don't need that anymore. Let's say we wanted to do this. Every time run gets called, we're going to do B plus equals 1. Just to show you what happens inside here, we've got B. And I'm going to change our variable name from run to count. And we're going to call count like that. Every time this gets called, this is going to be the first time it's going to be 2 because we're adding 1 to 1. And then it's going to be 3 because we're adding 1 to 2. Then it's going to be 4. And then it's going to be 5. We run our code. Sure enough, that is what happens. Closures are a child function will still have access to its parent's variables even after the parent is done running. Why wouldn't it? Well, without closures, the garbage collector would wipe out all variables. The garbage collector is just a fancy way, and I'll put that in quotes here, memory cleanup. When JavaScript gets to the end of a function, it will look to see, does this variable ever get used again? And if the answer is no, then it will wipe that variable out. Closures will prevent that because here parent is done running, but B is still necessary. Who does B belong to? It belongs right here. And this is really powerful because it means, and I'll throw one more note in here. Actually, let's do it down below. B inside of child, and I'm going to put slash count because we called it child up above, we call it count here, is absolutely private. No one will ever be able to get back to this variable because parent, it was initialized. It can never be changed again except by child with our count function here, okay? You use these all the time with, say, the fetch API or any callbacks that end up happening where a function gets returned. You just maybe don't see it. This is kind of a clever way to make closures work for you, but that is how they work. That is scope and closures. Thanks so much for watching. I'll see you next time on JavaScript Tuesday.